coming to you every week.
So, welcome, and today we are discussing an installation of GSM Commander. This is one of my own personal installations, and this is, as you can see, for a grow room, and we are growing all kinds of herbs. These are medicinal herbs, but we also have some things like that. That's my basil. It's hiding out here in the winter. So, I want to discuss how the Commander is making this grow room possible. So we've got our plants, we've got here a temperature and humidity sensor that communicates via Modbus. And we've got our lights, very, very powerful light. There in the back we have a heater. And we also have a humidifier, which I'll show you now. It's out of the room. And we've got our fans that are recirculating air inside here. So that's the basics. I'm a believer in living soil, so we've got a rich organic soil here with earthworms and all sorts of goodies inside there. So how do we control all of this? Well, we've got a enclosure here. Let me just switch on my light. There we go. So this is an example of how not to do your wiring panel. I could have, spent a few hours to neaten this up, but I decided, you know what, we are all human. And the reason it looks like this is because I'm chopping and changing all the time. When I'm at a point where this installation remains unchanged for at least a few months, then I might redo it and do it in a nice way. But while I'm playing with it, as much as I am, I just, boer maak 'n plan. So here's our GSM Commander. And this specific one is actually an early prototype because, it's for free. This one does not have a SIM card in it. Neither does it have an antenna because it's communicating via Wi-Fi only. So we've got our Modbus port that is connected to our temperature and humidity sensor that I showed you before, that one. So the Commander is actually measuring the temperature and humidity, and then it's controlling the heater that I showed you inside, and it's also controlling the humidifier. This is my humidifier. As with most of the stuff that I do, this is very much a homebrew setup. So I've got a big pipe that comes in from the room, and I've got an inline fan here that sucks the air out of the room and pushes it down. So I've got two of these crates on top of each other, and the bottom one, let me just open it. I'm going to quickly just disconnect these tubes. I'm going to open it for you. So here we have an ultrasonic mister, and it makes like a vapor smoke almost, and it sits in this cavity. So what happens is, and you'll see it's on a float, so regardless of the water level, the transducer is always sitting at the appropriate depth. So this fan is drawing air and blowing it across the surface of the water, pressurizing this bottom cavity, and that is pushing the wet air out of these two pipes and sending that back into my room. So let me just reconnect everything. There we go. That's how my humidifier works, and obviously the Commander is switching on that fan and the ultrasonic transducer when it wants to humidify the room. So if the humidity drops below what it needs to be, it will switch this on for a while. So inside here, that's our main power supply that supplies power to the Commander. The Commander has a 5x5 expansion connected that I'm using to control stuff, and there's a secondary power supply that is supplying power to the humidifier, to the actual ultrasonic thingy. We also have a big relay inside here. Maybe I shouldn't just touch anyway. That is used to switch on the light. So what we are trying to do is we're trying to simulate natural conditions. That's why this light is unbelievably bright. So that relay switches on the light for 18 hours a day. We are simulating summer at the moment. And it's also switching on and off the heater. Is using one of these outputs to switch on the heater. So the heater is just plugged in on this wire, and we are just switching this on and off as we trying to control the heater. Then we also have another room next door, another grow space. This is where I have my seedlings and my clones. We've got a much smaller light. There's one of the little babies. It's actually not doing that well. So this light is not white like the other one. We call this blurple. It's red and blue. So I use this for my small plants. And that light is also controlled from the Commander. But there's more. What else is this Commander doing? I've also got an aquaponics setup outside. And I've got a pump inside the aquaponics that is also controlled from this Commander. Let me quickly show you that. There we go. These are my fish inside my aquaponics system. And the water gets circulated. And I've got these grow beds. And the water is running there. All sorts of grow beds growing all sorts of, I've got a bunch of peppers, and I've got this is a lemon basil. We've got all sorts of things growing here. So this water gets circulated by a pump that's inside the sump. Let me show you the sump. So there's the sump. All the water runs back to the sump, and I've got a pump in there, and that pump is controlled by the Commander. Every few hours it switches the pump off for a few seconds to allow water to flow back and basically backwash the pump to prevent solids from blocking up the filter that's connected to the pump. So there you have it. I've got a bunch of stuff being controlled by the Commander. Future upgrades include control of an air conditioning system, and also I need to put in a float switch there so that I can be notified when the humidifier runs dry. So now the question is, how do we set up the Commander to do all of this? I will be showing you that next. Alright, now we're going to set up this thing. I've got my Commander connected on my PC. This is a different Commander than in the grow room, and we're going to interactively set this thing up. So the first thing we do, we're going to run this shortcut, and the software is going to open. There we go. That's what it looks like. And we're just going to say open a blank setup. Now the setup is like a program that you write that lives inside the Commander. So the purpose of this video is not to give you full training on the Commander and the software, but it is to show you how we use it specifically for this application. So I'm going to try and include as much detail as I can. So first thing we can see, it shows connected here at the top. Shows me that the Commander is indeed connected to this to the PC. So I can go ahead and connect to it, and I have my Commander running. So my status page shows me what's happening. I can see all sorts of information. I can see my variables, variable A through P, and I can see all my inputs and outputs. And I can also see a lot of information about what's going on inside the Commander. And also I've got a log here that shows me what's happening. The meat of this thing is happening here at behavior statements. So every statement sort of puts together what you want the Commander to do. And each statement consists of an if and a then. So I'm going to very simply quickly go and set this up to say if. So you can select an if and a then. So if this happens, then do that. So for instance, let us do the light for the grow light. Let us go and say if date and time. That'll be a good way to do it. So I could say I would like the light to switch on at 5 o'clock in the morning every day.
I want the light to switch on. So let's go and we will say change output. And we will select output 1 for this, and we will activate it, and we'll leave it activated. So this statement will switch on the light at 5 a.m. So we can put up another one. It says, all right, we'll do the same thing, and we'll say 2300. That would be 11 p.m. because I want the light to stay on for 18 hours. So at 11 p.m. I can say deactivate. That'll be one way to do it. There are many other ways, but that will suffice for now. So now we've got a timer to control the light. This is specifically for the veg cycle. So what else do we want to do? Well, we want to measure the temperature and the humidity. That's one of the most important things here. And I showed you in the video, we have that Modbus enabled temperature and humidity sensor. So we kind of need that variable to go and sit here. We need to get the temperature and the humidity into these variables. But before we do that, if you see this statement that we made was then activate output 1 and then deactivate output 1. It will be nice to not refer to output 1 because I'm going to forget which output is which. So it's maybe an idea to go and rename it. So we can call this grow light. And if we now go back to the statement, it will show then activate grow light and then deactivate grow light. That's certainly much better than just having output 1 and output 2. And you'll see here at IO names, we can also rename the variables. But the main problem is we want temperature and humidity to go in there. And we do that via what we call a Modbus mapping. So we are mapping an external device to read into one of our variables. So let's go do that. We'll go to Modbus mapping. And you'll see there is a little block here for each of the variables. And there's a bunch of stuff that you can fill out. I'm not going to go through all of it right now. If you want to read more, you can click the Please Explain button. This will automatically open up the manual. Let me just drag this in here. It will open up the manual and it will explain to you in much detail exactly how to do this and how it works and everything your heart could possibly desire. It will even show examples. It actually happens to show the exact example we're busy with, the temperature and humidity sensor. Does that look familiar? That little white jobby. So in here it explains everything. So I'm not going to repeat myself again. You can go read the manual. But there's an easy way. We can go and fill out all these fields, or we can say, well, let's use a predefined mapping. Because obviously we've done this a million times. So we have predefined a bunch of them. So there we've got our sensor. That happens to be this one, XY-MDO1, temperature and humidity. We go click on there, and then we ask it to populate the predefined mapping. I'm going to go click there. It says this will overwrite your existing mappings. Yes, we know that. And now it's going to tell me, there it says, the following mappings have been populated from predefined mappings, variable A and variable B. That will obviously be temperature and humidity. Let's click OK. And there you'll see it's filled out these blocks for variable A and for variable B. And you'll see it renamed it to temperature and humidity. Let's go back to our IO names. And you'll see there it sits. Now these variables have received their values. If we now go to status, we see nothing's happening. It's still showing 0. That is because we've got some setup now that we've done on the software, but we haven't actually written it down to the actual commander. So there's nothing happening on the commander side. So I'm going to say save setup to device, which will then sync up the two for us. See, there's writing the setup. And then the commander will restart. You can see here, it's restarting. And it's booting up, and it's doing all kinds of stuff. But immediately there we see, we've got 21 and 54. So that's 21 degrees Celsius, and that is 54% relative humidity. That's fantastic. Now that we're measuring something, now we'll be able to actually control something. So let's first start by controlling the temperature. And let's define how we will control the temperature. Let us, we actually lost our output. That was called grow light. It was overwritten when we did the Modbus mapping. So if we go back here, you will see our statement should still be there. There we go. So let's go and we use output 2 for the heater. Let's rename it to heater. Now, what do we want this thing to do? We want to say, well, if the temperature goes above the level that we want, or then it should switch off the heater. And if the temperature goes below what we want, then it should switch on the heater. Now, for me, I like to rather say, if the temperature is too low, then switch on the heater for a certain amount of time, so it will automatically switch off. So what I'm going to do, I'm going to say, if time elapsed, I want to execute this statement perhaps every 2 seconds. You'll see why. So every 2 seconds, no, I'm lying to you. I'm not going to say every 2 seconds. I'm going to say, sorry, let me correct myself. I'm going to say if variable, variable math. Where's my variable math? No, it's if variable, sorry. If my temperature is above, it's below 25, so I can choose here. If variable is above x, if variable is below x. So I'll say if the variable is below 25, then, and it stays below 25 for at least 5 seconds, then I want you to change an output. And in this case, I want you to switch on the heater. And you can switch it on for 10 seconds. So what's going to happen is this thing will trigger every 5 seconds. Because every 5 seconds, after 5 seconds of the temperature being too low, it will activate the output. So the moment the temperature is high enough, this thing will stop triggering, and eventually this 10 seconds will time out. And this creates my regulator, my temperature regulator. If I now say done, I get if temperature is and remains below 25 degrees for longer than 5 seconds, then activate the heater for 10 seconds. So that's my temperature controller right there. But one huge problem here is my temperature is now fixed. My control set point is at 25. I would actually like to have a variable set point. So let's do that. I'm going to create I'm going to call variable C. Well, let's make it variable F. Well, we call that temperature set point. That is much nicer. So if I now go back, I can say, well, I don't want to compare the temperature to a fixed amount. I want to compare the temperature to a variable amount. So there, you'll see it's fixed to 25. I can say, you know what? I want it to be variable. So compare it for me, with temperature set point. So now, if temperature is below the temperature set point, and it stays below the temperature set point for 5 seconds, then it will activate the heater. Bam. So now I've got a variable temperature. That's nice, but how do we determine what the temperature set point might be? Well, an easy way would be you can set that via a message. I think a great thing would be to maybe initialize that temperature when the device starts up. So we could say, well, if power up or reset, then we can change a variable and we will make the temperature set point. Let's make that equal to 26 degrees. So when the commander starts up, it will initialize that to 26. We can also say, well, I would like to be able to change that via a message from my phone. when I'm running the app or via SMS. So I could say if a message is received from any number in the list, I will just have to add my number into the list to make sure. And we'll say contains a message. Let's say we send temp up like that. So if the commander receives temp up, then we're going to change the variable, and we're going to add 1 to it. So every time we send temp up, then the temperature set point, sorry, not the temperature set point will increase by 1. That's very nice. But we also want to do another one for down. So I'm going to right click on it and say copy. And I'm going to say paste. That's because I'm lazy. And I'm going to say fine. I don't want to do temp up. I want to do temp down. So when I get temp down, then I will decrement. I will subtract 1 from the value. So there I've got a fully featured temperature controller. So let us save that to the device and see what it does. There it's writing. There it's restarting. All right. So we see the temperature set point is initialized to 26 automatically, and our current temperature is 21. And lo and behold, output 2 is active. Why? It's because output 2 happens to be our heater. So if we go back, we can actually see the statement triggering here. So every 5-6 seconds, you'll see the statement triggers, and it will keep that output on until such time as the temperature goes above. So let's make the set point. I can click on it and set it directly from the software. Let's set it to 20, which means the temperature is then above the set point. And you'll see after a few seconds it will time out and the heater will switch off. There we go. So you see it's off now. So my temperature regulator thermostat behavior is now fully working. And we also have our grow light. But remember, the grow light was at output 1. And we wanted the grow light to switch on at 5 and switch off at 11 p.m. Yet, if I look at my status, my output is off. That is a problem for me. I don't like that. The simple reason is because it will only fire tomorrow morning at 5. Is the time it will actually switch on. And it will only switch off at 11 p.m. So if my commander starts now, it's going to stay off until this statement is actually evaluated. So this will only happen when the time is 5 o'clock. And the time isn't 5 o'clock now. So there's a better way that I can actually do that. That will make it go to do exactly what I want. Let me delete those two. I'm going to put up a new, different type of statement. I'm going to say, if time elapsed is bigger than X, and I'm going to place that at 2 seconds, just for giggles. And I'm going to add a time constraint to that. And I'm going to say, well, I want this thing to run from 5 in the morning to 11 p.m. And I want it to happen every day of the week. There's no rest for the plants except between 11 and 5. So now what's going to happen, before the commander actually looks at the if, it will look at this. So this constrains the statement to only work between those times. So between those times, this statement will fire every 2 seconds. That's very, very handy. So we can then just say, change output, and we'll activate the grow light for 5 seconds. Because every 2 seconds, we are restarting the timer. So in effect, the grow light will remain on between those hours because of this constraint. So if I now say done, so now you can say, if you can now see it says, if 2 seconds have elapsed, then activate the grow light for 5 seconds. But you can see there's a time constraint. And the time constraint is what keeps it within the times that we want. If I now save this to the device, you'll see how nicely that operates. So in this, because I did it this way, I'm only using one statement, and I don't have to wait for tomorrow morning at 5. There's restarting. There's my temperature and humidity. And there's my heater coming on. We're just waiting for this thing to figure out what the time is. There we go. It received the time. It actually received it from the software, I think. No, it received it from the cellular network. And there the grow light switched on because the time is between 5 and 11 p.m. I hope that makes sense. So next up, we need to control the humidifier. We're now properly controlling the temperature, but we still need to control the humidifier. Now, certainly nothing prevents us from taking the same way that we did it with the temperature and just do the same for the humidity. And that is perfectly reasonable, except I'm actually not so interested in the humidity. I'm actually interested in the combination of temperature and humidity. And we call that vapor pressure deficit. That is the main reading that I'm actually interested in. And it's actually a pressure that you can calculate using temperature and humidity. It is actually a measure for how strongly does the air draw moisture out of your plant. So how badly is the plant having to transpire? Now we need to have control over that when we're doing indoor growth. So I would like for the commander to go and calculate the vapor pressure deficit on my behalf. So let's do that. We can go here and say if time elapsed, and we can say let's do that every 2 seconds, and then we are going to go and we're going to do 32-bit math. And you can do some math here, or you can select a vapor pressure calculator, a vapor pressure deficit calculator. So I can say, great, I would like you to put my VPD in variable C. But now you'll see you need air temperature. Great, we've got air temperature. And you need humidity. We've got the humidity. But we also need leaf temperature. Now, if you have a special infrared sensor that can measure the leaf temperature, then great. If not, what are you going to do? So what we are going to do, let's use variable C for leaf temperature. Now remember, we don't have leaf temperature now, but for now let's just assume we do, and we'll say done. So now this thing will go and calculate my vapor pressure deficit every 2 seconds, as long as I can have something in variable C that actually gives me my leaf temperature. Now we can assume the leaf temperature will always be close to the air temperature. Typically, it will be below, like 2 to 4 degrees below the air temperature. So we can just go and calculate it. We can put up a new statement that fires every 2 seconds, and we will again do some 32-bit math. And we're gonna go to this one that says 3 equations, and we're gonna say variable C will always be air temperature less a fixed value, and the fixed value is 3. So every 2 seconds, variable C will be populated with a value that is 3 degrees less than the air temperature, and that we can use for our leaf temperature. So let's go to IO names, and we rename variable C to leaf temperature. Now, we'll see those names will pull through. There's leaf temperature, but it's not updating yet because I haven't saved yet. But let's just check our setup again. So every 2 seconds, leaf temperature equals temperature minus 3. That's great. And then we've got here Then calculate VPD from temperature and leaf temperature and humidity and save the answer to, oh, not leaf temperature. We want the answer to be saved to VPD. Let's make that variable D. Let's maybe go give it a name. Variable D will be actual VPD. That's the value that I'm very interested in. So, just go check the statement. We'll see there it says, and save to actual VPD. Let's go and save this to the device and we'll run this. And there it starts. There's my temperature set point. That should probably come up to 26. Yes, there it is. There's my actual VPD, 721. So that'll be 0.721 kPa. And my leaf temperature is sitting at 18, which is 3 less than the air temperature. So there I'm fully calculating my VPD, which is for anybody doing an indoor grow, that is fantastic, because that's what we really want to know, and that's what we actually want to control for. So now that we actually have a measurement for the VPD, now we can control for it, and we can say, well, if the VPD is too low, too high, then it means the air is too dry. High is too dry. Low is too wet. So we can go and control the humidifier automatically from the actual VPD. Let's go do that. And for this, we'll do it very similar to what we've done with the temperature. We'll simply say, well, first, for the temperature, you remember we had a temperature up and a temperature down, and we had a temperature set point. So let's go do the same. Well, let's make a VPD set point. We'll call that variable G, VPD set point. That's where we want the VPD to be. Let us quickly do same thing that we did for the temperature. We'll initialize it at power up. We will say variable, select our VPD set point. A good number to start at is 1 kPa, which is 1000. And then we'll have messages similar to this, or statements similar to that. We'll say VPD up, and we will change. We're actually not going to use this. We will rather use 32-bit math, because we don't want to change it by one at a time. So we'll say target VPD set point equals VPD set point plus, we'll make it 100. So we can change the set point by 0.1 kPa at a time. And we'll make another one that says VPD down. And in this case, it will be minus 100. Very simple. So there I've got a nice way to control the set point of the VPD. Now we just need to put in the actual VPD controller. So we can say if variable, which variable? Our actual VPD. If our actual VPD is above our set point VPD. So if it's above X, and if it remains above X, well, let's make it a long time. Let's make it 10 seconds. If it remains above that for 10 seconds, then I will activate my humidifier. Let's put the humidifier on output 3, and we'll activate it for 20 seconds. So for as long as the VPD is too high, this statement will trigger every 10 seconds, and it will actually activate this output for 20 seconds. So it will remain on until such time as the VPD comes within spec. So if I say done, if actual VPD is and remains above VPD set point for longer than 10 seconds, then activate output 3 for 20 seconds. Now you can guess what I'm going to do. I want to rename output 3 to humidifier. There we go. Now it will read slightly nicer. It will say then activate humidifier for 20 seconds. So I can say save setup to device, and we'll see what happens again. So we should see the set point come up to 1000 when it starts. There we go. Here's our actual VPD. And you see the actual VPD is now significantly below the set point. So the humidifier will remain off. But we can go and cook the set point. Let's change the set point and we call it 650 by just entering the value there like that. So I just clicked on it and then it brings up the little box where I can edit it. So now all of a sudden my actual VPD is above the set point, so it's too dry, which means it switches on. There it switched on the humidifier, and it will stay on until this set point, or until the VPD comes down. So in this case, let's take it back up to 1000. There we go. So you'll see, there it goes. We should see that output switching off. Because remember, it stayed on for 20 seconds. So it's going to take at least 20 seconds for this output 3 to there it drops out. So now the humidifier is off again. So that is pretty simple. So now we've got control over the light. We've got control over the temperature. And then we've got direct control over the VPD, which is flipping amazing. There's a bunch of other stuff we could add, but for now, this indicates it very, very well. This device can obviously communicate via the AirDrive service. It can communicate to our app. So just want to quickly show you what it looks like. This is on my personal phone. There I've got, this is a screenshot from my app. So you can see, I can see my temperature and my humidity. This is my actual VPD as it's being measured, and that is the target VPD, which is 1.1. I can see my temperature target, and I can also see how active has my humidifier been. So 42% of the time that humidifier is running. That's very nice, so I can know whether I've got control authority over my VPD. If I see the humidifier is active for 100% and the actual VPD is significantly higher than my target, then I've got a problem. Then my humidifier is probably run dry. And I can also see that my humidifier and my heater are both currently off. So that just shows you how easily you can go and create amazing behavior using the Commander. And I trust this has been quite interesting. Let me know if you have any questions, and thanks for watching.
Wireless Wednesdays coming to you every week.